Okay, now we're starting the recording, all right? And so if we were to start to think about some questions, well, we're going to try to do our best with the PowerPoints that we have and the book that we have. Does everybody have access to the Moodle? Okay. If you don't have access to Moodle, please let me know. That would be do not mute or unmute yourself and let me know if you have problems. Okay, number two, does everybody have a textbook? I can imagine that the textbook might have been left at school. Okay, so we need Moodle and we need the textbook, and we're going to be using this platform, Zoom, to start to think about going through the PowerPoints. I want to be able to reference the book on occasions, and I will be assigning homework. That would be reading the textbook and doing problems. And we'll start with that as a premise. Now, in terms of assessments, assessments are going to be kind of difficult to do because number one, we have to make a quiz or an exam, and then we need to deliver it to you while you're at home. Now, I am thinking about this, and I want to, if we were to be in this situation for the rest of the semester, I'm thinking about a final exam. And in addition to a final exam, which will be on the exam day that's been already scheduled, I'm going to be doing one, probably two quizzes, all right? Now the assessments, the exams and the quizzes haven't really been solidified yet. That means that I haven't scheduled them. I don't know what the quiz or exam would be, but that is my intention. Questions? All right, now I'm going to rely on everyone to feel comfortable about getting their questions answered, right? So what I would wish to do, if you have a question, just for sort of the record, we want to introduce yourself and then ask your question, and then we might have a discussion that goes along with that, all right? So I'm assuming when I say, do you have any questions, that everybody doesn't have questions. Is that right? Okay.
Mm-hmm. Yeah.
Anybody have questions? Okay.
Actually, I have one.
Go ahead.
So I know that the quizzes, like, and just the assessments in general, they aren't solidified in terms of like how they'll look, but is it solidified that we will have them?
That is true.
Okay. Thank you.
So it probably might be a one question quiz.
Will
right?
they be announced?
Of course.
Okay.
Yes, I understand what you're dealing with because I'm dealing with the same problems. Okay. So I'm not in the position to be too held to the assessments. I'm going to start to think about the homework and the homework that you're doing and the completeness and carefulness that you do the homework as a much more majority of the final grade. Does everybody understand that?
Yeah, thank you.
Okay. So we're changing sort of our idea of taking a quiz in the classroom because I can't really do that anymore. I can't monitor or proctor an exam or a quiz. So I'm reaching out to you, suggesting that we use less exams, maybe more quizzes, and I want to try to put a final exam together. Does everybody understand that? Questions?
I have a question, sir.
Yes, sir. Who are
It's Trinity.
great?
So you said that we might have, or we may need a scanner and a printer. Does that
Right.
still stand?
Okay, I would like to see your homework. Okay, after it's completed, I would like to see your homework in a PDF file.
Okay.
Okay, and I want you to email it to me.
Okay.
Does everybody hear that?
Mm-hmm.
Okay, I've already had another section. They're sending me photos. I do not want the photos. I want a PDF so that I can actually see it and I can grade it. Does that make sense?
Okay, yes, thank you.
Anybody else along those lines? Okay. Now, I will be recording each one of these sessions, and I will put it up on Moodle so that you can go through it again if you wish. And so that is one of the maybe benefits for this platform. Other questions? Okay, so I'm trying my best, okay, to use this hour because it is our normal hour. I know 9 o'clock is it's tough to get up and get ready. Okay, so I need, okay, to have some, some structure here. So I'm going to do these sessions mainly around 9 o'clock, Monday, Wednesday, or Friday, okay? Now, for example, I might send you off to read the text and do homework, for example, on Monday. So we're not going to have a session like this on Monday. You're going to be given homework, reading the book, and doing the problems that are assigned.
Is that for this Monday?
That is for this Monday. That's right. Okay. And I'll see you on Wednesday and Friday of this of next week. Okay. Does everybody sort of hear that? Questions about that? Okay. So we're going to lean on the PowerPoints and we're going to lean on the textbook to get course material delivered. Okay. And then we'll come back and start to think about questions that come along with the reading and with the problems. And we'll go in that sort of way.
I have one question. I'm so sorry.
So,
I'm trying to get everything set up, so I might have missed it. But did you say that with the homeworks, is that still being graded for completeness, or is that like actually being graded for correctness?
I would use a lot of extra energy on getting those homeworks looking really good. And we will probably use some sample practice problems, okay? And you have access, I think, to, if you have the textbook, you have access to the answers for every odd problem. Do you understand that?
Yes.
Okay, so in that vein, I think I have maybe a handful, maybe 2 or 3 even not problems here for our homework. Okay, most of them are the odd problems so that you can understand what the answer would be. Now, I hope that you don't go to the answers and make that part of your homework. I'd like you to do it without without the answers, and then you can use the answers after you have completed it, and maybe have a revision of the homework. Does that answer the question?
Yes. Thank you.
Okay. Anybody else? All right. So some of the things that you may want to ask me, obviously we're going to be using this platform, Zoom, and we'll also be obviously using email. Okay, does everybody sort of see that? So I know that we're going to get a lot of emails and a lot of questions, and we'll try to fight our way through that. Again, questions?
Are we turning our homework via email or on Moodle?
I would like the homework in a PDF file and delivered to me by email.
Okay.
Okay. Everybody sort of see that? Okay. Other questions? Okay, are we moving on to lecture material? Okay. Now, what I'm going to do here is I'm going to share the screen with the PowerPoint. Okay. Does everybody see the PowerPoint? Please confirm.
Yes.
Okay. So I'm starting with chapter number 5. Okay, chapter number 5. And we've already started this chapter, and I don't really want to go all the way back to the beginning, but I do need to start to think about some of the details that we want to get on board with. Okay, and the first thing we are thinking about after the linear regression line, we'll want to get the square correlation. And I think we went through this pretty rigorously when we were in our classroom. And we went through the language that goes along with the correlation squared and what it might mean. So these are the same PowerPoints that you already have seen. Is that true?
Yes.
Okay. All right. I think we went through this too. Now, I think we actually we showed how to use these data, okay, in our calculator. Is that true? Does everybody understand how to use this in their calculator? Please let me know if you don't. Okay.
Can you maybe go over it one more time?
Okay,
It's
very
been a
good.
little
Thank
bit.
you. Thank you. Okay, does everybody have their calculator out?
Yes.
Okay. So you go to stat, all right, and you would first use edit, and that would hold your data, okay? So you have your data that is in that function. Everybody see that? Now, do we need to go back to the data? There's the data, okay? So I'm just giving you a view of what the data for this particular problem was. Do you remember this in your calculator?
Yes.
Okay. And then we want to start to think about a regression line. And what we would do is we would go to stat, over to calc. We would run our, we want the function of 8, linear regression, A plus B times X. We want to enter that. And then you put the list in the edit, okay? So these are the data. The first column is the X values, and the second column is the Y values. Okay, and we don't want to mix them up. We want to keep them straight, all right? So this is the linear regression y hat equals 3.51 minus 0.0034. All right, so this is what the least squares regression line for these data. This is the data that we're talking, this is the line that we're talking about. And that's seen here in the red line that goes along with the data. Everybody sort of see that? So once you get to calculate on your calculator, you'll see these data here. Now the first thing that you'll see is the intercept. The second thing that you'll see is the slope. This is the intercept. This is the slope. And then you might see also R squared and then R on your answer. Does everybody see that?
Yes.
Anybody that does anybody not see the R values?
I don't think I have that on mine.
Okay. Yes, ma'am. So let me go through a brief understanding how to get that on there. You go second, all the way down to 0, and you'll see category right above it. Okay, so you press that, and you want to, in the catalog, you want to go down to diagnostics. Are you following me?
Yes.
Okay, great. All the way down, and it's going to be diagnostics. Okay.
So
All right.
I would turn diagnostics on.
Yes, that's right. Okay. And you'll have to do that a couple of ways. And once you see the word done, you should see the R values in the calculation of linear regression. Is that true?
Yes. Yes.
Okay, fantastic.
Thank you.
All right, everybody with us?
Mhm.
Okay. So while I have this particular slide up on the screen, I want to do a couple things that leads us to predictions via regression lines. Okay, so we're taking this linear regression line right here, and we're going to substitute 400 for x. Okay, 400 for x. And if you see in the figure, you have a blue line going up to the line and over to the y-axis. And then this represents then y hat, or the predicted y, given that x is equal to 400. Okay. And so I have given you the answer to the x hat, the y hat, and that would be 2.145. This is a very important part of linear regression. So I'm going to wait a little bit and have everybody think about it. Are there questions?
No.
Okay. All right, this picture here gives us a chance to look at what we want to do with our calculator. Okay, on the top right corner, and all the other things that go along with examples of technology.
Is R squared for Y? I mean, R for Y hat and R squared for the residuals?
Okay. So R is the correlation coefficient.
Yeah.
Okay.
For Y hat, right? Or the least squares regression line.
Okay. R is the correlation.
Mm-hmm.
Okay. And it really isn't about any line. It's about the association between X and Y as variables.
Okay.
Okay.
Yeah.
Now, if we were to look at this picture right up here in the top corner, right corner, you have R is equal to negative 0.779. Okay, that's the correlation coefficient.
Mm-hmm.
R squared is the what would be called the coefficient of determination.
Oh,
Okay, and that is simply squaring the value of R.
okay.
Okay,
Thank you.
and just to go back one step here. Okay. Okay, so here is the explanation for squaring the correlation coefficient, right? And we went through this, I believe, pretty rigorously. Does everybody understand this? So that when we're thinking about that other R value, R squared, that's what this is right here.
So is the total variation in observed values of y, is that just how many values of x there are or y?
Okay,
I
so,
don't think we went over that.
okay, again, I think we did the, can somebody confirm that we actually went through this?
I don't remember going over this.
Okay,
I was about to agree. I don't remember it either.
okay,
I remember the slide below it, so we probably touched on it, but it
right,
was a while ago.
okay, all right. So let's just go ahead and say what it is. The square of the correlation, okay, and that symbol is R squared, is the fraction of the variation in Y, okay, the proportion of the variation in Y that is explained by the variation in X is explained by the least squares regression line. That is Y on X. So it's a value that says how much variation of the Y values are explained or attributed to the X values. Does everybody sort of see that? The proportion of the variance in Y values as attributable to the variance in the X values. Questions? So here is, again, one of the things that you might see with the linear regression function. You can see that negative 0.779 is the correlation coefficient. And if we were to square that value, it would be equal to 0.606. So 60.6% of the Y variation is explained by the X variation. Okay, so do you understand what this might be? What would you say about the strength of this association here?
Which one?
Start with the correlation coefficient.
So a strong negative correlation?
Okay, I'll let you buy on that. Maybe it's a little moderate, or maybe it is a little strong. We don't see the data.
Mhm.
But then you can say the R squared is the proportion of the variance in y that can be explained by the variance in x. All right, so it's a little bit tricky, but that is what we're thinking about here. So that explains this particular slide. Questions? Okay. Now, it seems to me that we might want to go back and look at the facts about least squares regression. Okay, so what is this equation right here? What does B equal? So the slope is B, right? What is R?
Correlation coefficient.
Okay, what is S sub Y?
So the standard deviation of y.
Okay, the standard deviation of the Y values.
Mm-hmm.
Okay, and likewise, the S sub X is the standard deviation of the X values. Okay, so what this slide is saying, that is the slope and the correlation coefficient have very reciprocal like responses. So they have the same sign and they change accordingly with the strength of the association. Okay. Questions about this? All right, so this last bullet, what does this have to do with the least squares regression line? Okay, well, if you were to take the mean of the X values and the mean of the Y values, that set of data, that pair, the two means, will be on the regression line. And it will always be that way. So X bar and Y bar are the means of the X and Y values, and that pair will find its way on the regression line. Questions? Is everybody following? Please ask questions. Okay. So I think I heard someone say that we have seen this slide before. So this gives us our regression line. It gives us the correlation coefficient, and it gives us the R squared value. Questions?
No.
Okay. I'm hoping that everybody is up to speed with that. Okay. I refer you to page 143 and that discussion about the facts about least squared regression. All right. So residuals. Okay. So there are two different versions of the Y value. All right. We have the observed value and we have the predicted value. All right, let's take a look at this value right here. Okay, I have my point on a dot here that is just above about 200 on the x-axis and approximately about 2.4 on the y-axis. Okay. So let me just jump in here and I'm going to insert a text and say, okay, what is that value again? About 110 and 2.4. Okay, that defines this this dot right here. Does everybody sort of see that? Okay, so this is the observed value. That is 2.4 is the observed value. That's the Y value that is actually an observed value. All right. So if we go from this this point right here up to the line, what is the predicted Y value now? Let's go back, show it. So what I'm asking is, what is the difference between the observed and the predicted? What would you estimate as the predicted? Okay, let's everybody get their calculator out. All right, does everybody have a calculator?
Yes.
Okay, so this equation right here is our linear regression equation. Everybody see that? Okay, if we were to substitute 210 into the x value here, what would be the predicted Y? So can somebody do that for me, please?
$2.7911.
Okay. So let's just go ahead and put that value down. What was the value again?
2.79 to 2.8.
2.8. Okay. All right, let's take those two numbers and we want to subtract. We want to subtract the observed and the predicted. What would be that value?
-0.4.
-0.4. Right? Everybody sort of see this. Okay, what is then this difference here? That is called a residual. -0.4 is called a residual. Okay, how many residuals will we have for this particular data set?
The same amount of points.
The amount of points, okay? Whatever the sample size is here is going to be the number of residuals that we could see, all right? So here is the residuals. All right, so the residuals is the difference between the observed value on the response variable and the value that is predicted by the regression line. That is, the residual is a prediction error that remains after we have used a value of X. So here is another equation to be thought about. Questions? Okay.
The residuals always equal 0, right?
Okay.
Or something like that.
That's an interesting question, okay? Say you had 20 residuals, okay? Some of them are going to be positive, some of them are going to be negative, as you can see in this picture right here. These will be negative under the line, and these will be positive on above the line. And if you were to take all 20 residuals and sum them up, the sum of the residuals will be 0. Okay? All right. So let me get to my slide. Obviously, I was a bit ambitious today. So let's go ahead and just drop this into right here. So here is the homework for the weekend. Okay. I want you to read pages 135 to 151. Okay, and on page 123 and 124 are problems that relate to correlation. That's chapter 4. So this here is chapter 4. And then chapter 5 is right here, starting with page 163 to 164. And then these here are then the problems that I want to have you do over the weekend. Questions? Now again, with these problems, the odd values, that being 29, 31, and so forth, those problems you have the answers to the particular chapter that we're thinking about. Question? Excuse me.
This is due on Monday, not Wednesday, correct?
This is due on Wednesday.
Oh, perfect.
Okay. So I'm going to give you some time. We're going to use this this time slot here on Monday, Wednesday, and Friday. I'm going to give you class time on Monday to read the chapter, not really the chapter, but the pages that are assigned, and do the problems that go along with it. With Wednesday's meeting, we're going to meet on Wednesday, same time, 9 o'clock, and we'll go through a couple problems and get into different material.
When you say that we will have class time on Monday to do this, so we still have class on Monday, but we're going to be doing this.
We will not be meeting on Monday. Does
Okay,
that
I was
answer
just
the
a little
question?
confused there.
Did I clear it up?
Yeah.
Okay, very good. Okay, now, how did we do?
It was okay. It's all good. We'll get some getting used to, but that was organized. So thank
Okay.
you.
All right.
There was no issues on the technical aspect, so that was good.
Yes, sir. That I agree. Okay. Well, we'll practice, and I still have a long journey to go in delivering in this way. Okay.
Thank
So
you.
Thank
You
you.
have a nice
Thank you
day.
very much.
Have a great
weekend.
day.
Thank
Thank
you.
you.